Welcome back. Today we're going to use the idea of slope and y-intercept to graph equations. So let's say that we have an equation right here and we want to graph the equation. Now we've looked at methods before where we've created tables. We could create tables with values in order to graph the equation. But another quick way of doing this is actually to use the slope and the y-intercept to graph it. So let me highlight the slope, right? I'll put a key here. That's the slope, and this is the y-intercept. Remember, it's -1 because we include the operation there. So here, this is slope, and this is y-intercept. Okay. Now, step number 1 for graphing it is actually just to use the y-intercept, and remember that the y-intercept is a coordinate. Right? The y-intercept is the y value when the x-coordinate is 0. So we can just translate that into the coordinate 0, -1. So from the origin, I go 0, left and right, and I go down by -1. So this is a point on the graph right here. Okay? Now, from here, we are going to use the slope in order to find different points. So remember that 2/3 is saying that between any 2 points in the line, you have a rise of 2 and a run of 3, or anything equivalent to that. So for instance, this is +2 over +3. So, and remember, it's rise over run. So you want to think of this as going up 2 and to the right by 3, okay? So we want to go not from the origin, all right? We're going from the y-intercept. So from the y-intercept, we want to go up 1, 2, and right 1, 2, 3, and that will get us another point right there. And if we check, that point is 3, 1, and if I put it through the equation, y equals 2/3 times 3 plus -1, this should be equal to 1, this value right here. So y is equal to 2/3 times 3 over 1 would be 6/3, which is 2, plus -1. Well, y would be equal to 1, which is what the x-coordinate is here. So this point, in other words, this point is a solution to this equation up here, which is what we would expect because we went from the y-intercept and we got another point on the line. Okay, what I also want you to remember is that 2/3 is equivalent to -2 over -3, right? 2 negatives divided, because these are both just equivalent to the decimal 0.6 repeating. Now, we don't really need the decimal in this regard because we're going to use the slope here, but I just want you to remember this because this is equivalent to making a move of down 2 and left by 3. Okay, when you have a negative in the horizontal movement, it makes you go left. When you have a negative in the vertical movement, it makes you go down. Okay, so we from this point right here, we could also have gone down 1, 2 and gone left 1, 2, 3. What you'll notice about these 3 points is that they are collinear, meaning they create a straight line. So let me go do it again. 1, 2, 1, 2, 3. There's a point in the line, and up 1, 2, and over 1, 2, 3. Right? Also notice that anything equivalent to 2/3 would have worked here. So for instance, if I did, let's say that 2/3 is equivalent to 4/6. So from this point, I could have gone up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. I would have determined this point instead of this point, that was the first point I determined here. But it's the same thing, right? Any fraction, any rise over 1 that's going to be equivalent to the fraction 2/3 will get you another point on the line. All right, and my last move is to actually draw a line through the points. So remember to make your line as long as possible, and you actually want to go ahead and put arrowheads on it. It's not correct unless it's an actual line, not a line segment. And you want to write the equation on the line. Y equals 2/3 x minus 1. Okay? Let's try another example. Y equals -3x plus 4. So here the y-intercept is 4. So let's highlight that. This is the y-intercept, that's 4. And the slope is -3. So notice that's the same highlight colors that I used before, so you might want to carry that through with your notes so that you have a little key for this lesson for your highlights. So here, the first step is to plot the y-intercept to remember that this is equal to 0, 4. So you plot the point 0,4, which is right here. Okay, and then what's strange is that -3, by the look of it, isn't a ratio, but certainly I could put -3 over 1, and it becomes the ratio of rise over run. So if your slope is an integer, right, a whole number or its opposite, then just put it over 1, and then you can get both the rise and the run. All right, so this means that the rise is negative. When you have a negative rise, it means down by 3. And when you have a positive run, you're going to have right by 1. So if I go down 1, 2, 3, and I go right 1, I'm going to get another point on that line. I could have also gone, remember, -3 over 1 is the same as 3 over -1. They both simplified to -3, so I also could have gone this would be up 3 and left 1. So if I had gone from this area here, I go up 3, 1, 2, 3, and left 1, I would have gotten this point. All right, since here I can't go up 3, there's not enough space on my graph, I'm going to continue to go down 3 and right 1. 1, 2, 3, right 1, 1, 2, 3, right 1. And that's as many as I can fit on my graph. So that's going to get me a nice line right here. So we're going to draw our line through it. Now notice that I sort of made my line a little crooked. I'm going to go back and fix it. Make sure to draw your line as long as you can in the space that you've been given. Always go back and put your arrowheads in. Okay, and then write the equation of the line on here. Now it's not easy to turn my screen, but it's easier for you to turn your paper so that the equation lies right on the line. But this was the equation up here. Always write it on top of your line. Okay? Let's say that I've just been given the slope and the y-intercept. So again, you could always just put this back into the formula, y equals mx plus b. But just given this, you should be able to determine what the line is. So the y-intercept is 1. We're going to recall that that's equal to 0, 1, so that's right here. And the slope is 1 over 2, so I go 1 over 2 would be up 1. And right 2. Equivalently, I can go down 1 and left, oops, I forgot to put 2, left 2, right? Because that would be equivalent to -1 over -2, which is equivalent to 1/2. So I can go up 1 and right 1, 2. And then to fill it out, I can go down 1 and left 2. And that gets me a point that's collinear. Okay, so here are my points here. Let me go ahead and draw my line. Put my arrowheads in and write my equation. Okay, now let's try one quick word problem here and then we're finished. So Ken has a weekly goal of burning calories by taking brisk walks. The equation y equals -300x plus 2,400 represents the number of calories y that Ken has left to burn after x hours of walking. So this right here is hours. Okay, so his initial value here is 2,400. So he starts with 2,400 calories, and notice your slope is negative. So whenever you put in a positive value for your hours, like say I put in 1 hour, for instance, because this is going to answer this question right here. What happens if you put in 1 hour here? Well, if I take -300 and I multiply it by 1, and I add that to 2,400, what I'm going to get is, so 24, it's -300 plus 2,400, which means that he's lost, it goes down to 2,100. That's equal to y. So that means that he's down to 2,100 calories. So he's losing, every hour that you put in, he's losing 300 calories. So how many calories does Ken burn by walking 300? By walking 1 hour, he loses 300 calories per hour. Notice I don't say that he's burning is the same thing as losing, right? When you burn calories, it means you no longer have to store them into your fat. So the idea is that he's getting rid of them, right? But notice that I don't put -300, because if I use a sentence like he burns 300 calories, the negative is indicated by the word burns. All right, so just be careful when you're answering word problems. The sign of the slope is often indicated by some word in the word problem, like burn. Okay, how many calories does he burn? That means he's losing calories. Okay, I can say that Ken burns 300 calories per hour. All right. And then we want to graph the equation. Well, here the initial value is 2,400. That's your y-intercept. So I'm going to go ahead and put that on this graph right here. So it looks like this is going up by 100, or it's actually going up by 500. So if I make 1, 2, 3, 4, this would be the fifth one, then 2,400 would be here. Okay. And then every hour so on hour 1, he's at 2,100, like this. Okay, and then after hour 2, he's going to be at 1,800, about here. After hour 3, he's going to be have lost 900, so it'll be 1,500, right? Okay, and that's actually good enough for me to make a line just by using those points, because I can just drag the line through those points like that. Like you would use a ruler in order to make that line, and it would be going down through other points here. So actually, we also know, by the way, that after 8 hours, because if I put 8 into this equation, it would be negative 300 times 8, which would be 2,400. If I added that to 2,400, I would get a y value of 0. So we actually know that it crosses the the x-axis at 8. So let me just sort of fool around like that. Okay, there we go. So there's our line right here. And I actually don't have to put arrowheads in here because the line doesn't extend, for this word problem, it doesn't make sense for negative values of x or y, so I don't have to imagine that this extends into the other quadrants. Okay? And then I would finish this off by writing the equation on here. All right. So what you learned how to do today was take slope and y-intercept, and by using the y-intercept, plot a point and use the slope to find other points to draw a line through them. And that's the end of the lesson for today.